There is no code provision against putting a dwelling unit bathroom light on the ground fault circuit interrupter, or GFCI, protected side of the receptacle. However, it is generally considered good practice to separate the lighting circuit from the GFCI protected circuit and keep the fans on their own circuit. This is a common sense approach that is used to control different elements within the bathroom independently while meeting necessary safety requirements. Here are some of the reasons why it is not done. Firstly, consider safety. If the GFCI trips, the light will also turn off, leaving the bathroom in darkness. This could be a hazard in an emergency. Secondly, consider convenience. It is more convenient to be able to turn the light on and off independently of the fan. Thirdly, consider code compliance. The National Electrical Code, or NEC, requires that bathroom lighting circuits be on a separate circuit from the GFCI protected receptacles. This is to ensure that the lighting will remain on even if the GFCI trips. In the specific scenario of a client wanting light and fan timer switches, and the fan being located in the shower, the recommendation remains to wire the fan on a separate circuit from the light. This way, the fan will still be protected by the GFCI, but the light will remain on even if the GFCI trips. To elaborate further, let's break down the typical bathroom wiring scenario and how GFCI protection integrates. A standard bathroom often includes a receptacle, lighting fixture, and potentially an exhaust fan. The NEC mandates GFCI protection for receptacles in bathrooms due to the increased risk of electric shock near water. This protection is typically achieved by installing a GFCI receptacle or GFCI circuit breaker that protects the entire circuit. Now, the question arises about including the bathroom lighting on this GFCI protected circuit. While not explicitly prohibited, there are several reasons to avoid this configuration. The primary concern is the potential for nuisance tripping. GFCIs are designed to detect even small imbalances in current, indicating a leakage to ground. A faulty ballast in a fluorescent light, a loose wire, or even condensation can sometimes trigger a GFCI trip. If the bathroom light is in the GFCI protected circuit, a trip will plunge the bathroom into darkness, which can be dangerous, especially for children, the elderly, or individuals with mobility issues. Furthermore, consider the functionality of a bathroom. Lights are essential for performing daily tasks such as showering, shaving, and using the toilet. Having the light unexpectedly shut off due to a GFCI trip can be disruptive and inconvenient. Separating the lighting and receptacle circuits provides a level of redundancy. If the GFCI trips due to a fault in an appliance plugged into the receptacle, the lighting will remain operational. In addition, exhaust fans, particularly those installed inside the shower enclosure, require GFCI protection. This is to safeguard against electrical hazards associated with moisture and proximity to water. However, the same concerns about nuisance tripping apply to the fan. If the fan motor develops a fault or encounters excessive moisture, it could trip the GFCI, potentially affecting the lighting if both are on the same circuit. The most practical approach is to dedicate a separate circuit for the bathroom lighting, a separate circuit for the GFCI protected receptacle, and potentially a third circuit for the exhaust fan, especially if it includes a heater. This configuration provides the highest level of safety, convenience, and reliability. Here are some additional points to consider. Firstly, ensure all wiring complies with the latest edition of the NEC and local electrical codes. Secondly, use appropriately rated wiring and components for the intended application. Thirdly, install GFCI protection devices that are listed and labeled by a recognized testing laboratory. Fourthly, periodically test the GFCI devices to ensure they are functioning correctly. This is typically done by pressing the test button on the GFCI receptacle or circuit breaker. Fifthly, educate the homeowner or building occupant about the purpose of GFCI protection and the importance of not tampering with the electrical system. Now let's delve deeper into the NEC requirements. Article 210. 11 of the NEC specifies branch circuit requirements for dwelling units. While it does not explicitly prohibit placing bathroom lighting on a GFCI protected circuit, it emphasizes the need for sufficient branch circuits to serve the intended load. Section 210. 8 addresses GFCI protection requirements. It mandates GFCI protection for 125 volts, 15 amps and 20 amps receptacles installed in bathrooms. It also requires GFCI protection for other locations such as kitchens, garages, and outdoor areas. Section 404. 8 covers the installation of switches in wet locations. It requires that switches installed within reach of bathtubs or showers be GFCI protected. This typically applies to switches that control exhaust fans or lighting fixtures located directly above or within the shower enclosure. Regarding the light and fan timer switch scenario, it's crucial to ensure that the switch is properly rated for the intended load and that it is installed in accordance with the manufacturer's instructions. If the switch is located within reach of the shower, it must be GFCI protected. In the specific situation described, where the client wants the fan to continue running after the switch is turned off, it's even more critical to isolate the fan circuit from the lighting circuit. This prevents the light from turning off when the timer activates the fan's run-on feature. To achieve this, you could wire the fan to a separate GFCI protected circuit and use a timer switch specifically designed for exhaust fans. These switches typically have a neutral connection and a built-in timer that allows the fan to run for a predetermined period after the switch is turned off. The lighting circuit would then be wired separately without GFCI protection unless required by local codes. When wiring the fan, ensure that the GFCI protection is provided upstream of the timer switch. This ensures that the entire fan circuit, including the timer, is protected against ground faults. Use appropriately sized conductors and ensure all connections are properly made and tightened. Consider the voltage drop in this circuit, especially if the fan is located a significant distance from the electrical panel. Voltage drop can affect the performance of the fan and can even damage the motor over time. Use a voltage drop calculator to determine the appropriate conductor size for the circuit. Furthermore, be mindful of the ampacity of the circuit. Ensure that the circuit breaker or fuse protecting the circuit is properly sized to handle the combined load of the fan and any other devices connected to the circuit. Do not overload the circuit, as this can create a fire hazard. In addition to GFCI protection, consider using arc fault circuit interrupters, or RFCIs, for the lighting circuit. RFCIs are designed to detect arc faults, which are a common cause of electrical fires. They provide an additional layer of protection against electrical hazards. When installing electrical devices in bathrooms, always follow the manufacturer's instructions and the requirements of the NEC and local electrical codes. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricity can be dangerous, and improper wiring can create a fire hazard or electric shock hazard. In summary, while there is no explicit code provision prohibiting the placement of bathroom lighting on a GFCI protected circuit, it is generally not recommended due to safety, convenience, and code compliance considerations. Separating the lighting and receptacle circuits provides a higher level of redundancy and reduces the risk of nuisance tripping. Wiring the fan on a separate circuit, especially when using a timer switch, ensures that the light remains on even when the fan is running. Always follow the NEC and local electrical codes and hire a qualified electrician if you are not comfortable working with electricity. Remember that safety is the top priority when working with electrical systems. Always turn off the power to the circuit before working on any wiring. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Double-check all connections before restoring power to the circuit. By following these guidelines, you can ensure a safe and reliable electrical system in the bathroom. Here are some additional details on how to properly wire a bathroom fan with a timer switch and GFCI protection. Firstly, identify the circuit breaker that supplies power to the bathroom. Turn off the breaker to de-energize the circuit. Secondly, locate the existing wiring for the bathroom fan. This typically consists of a black wire, a white wire, and a ground wire. Thirdly, install a GFCI receptacle or circuit breaker on the circuit. This will provide GFCI protection for the fan. Fourthly, wire the fan to the GFCI receptacle or circuit breaker. Connect the black wire from the fan to the load side of the GFCI receptacle or circuit breaker. Connect the white wire from the fan to the neutral side of the GFCI receptacle or circuit breaker. Connect the ground wire from the fan to the ground terminal on the GFCI receptacle or circuit breaker. Fifthly, install the timer switch. Follow the manufacturer's instructions for wiring the timer switch. Typically, the timer switch will have a hot wire, a neutral wire, and a load wire. Connect the hot wire from the timer switch to the load side of the GFCI receptacle or circuit breaker. Connect the neutral wire from the timer switch to the neutral side of the GFCI receptacle or circuit breaker. Connect the load wire from the timer switch to the black wire of the fan. Sixthly, test the installation. Turn on the circuit breaker to energize the circuit. Test the GFCI receptacle or circuit breaker to ensure it is functioning properly. Turn on the fan to ensure it is operating correctly. Set the timer switch to the desired run-on time. Verify that the fan continues to run for the specified time after the switch is turned off. Seventhly, label the circuit breaker. Clearly label the circuit breaker that supplies power to the bathroom fan. This will help prevent accidental disconnection of the fan in the future. Eighthly, document the installation. Keep a record of the wiring diagram and the components used in the installation. This will be helpful for future maintenance or repairs. Ninthly, inform the homeowner or building occupant about the operation of the fan and the timer switch. Explain how to test the GFCI receptacle or circuit breaker and what to do if it trips. Tenthly, inspect the installation periodically. Check the wiring and components for any signs of damage or wear. Test the GFCI receptacle or circuit breaker regularly to ensure it is functioning properly. By following these steps, you can ensure that the bathroom fan is properly wired with GFCI protection and a timer switch, providing a safe and convenient ventilation solution. In addition, it is important to consider the location of the fan. If the fan is located directly above a shower or bathtub, it must be rated for wet locations. This means that the fan is designed to withstand exposure to moisture and water. If the fan is not rated for wet locations, it could pose an electrical hazard. It is also important to ensure that the fan is properly grounded. This will help to prevent electric shock in the event of a fault. The ground wire should be connected to a grounded metal box or a grounding electrode conductor. When selecting a timer switch, choose one that is compatible with the fan. Some fans require a specific type of timer switch. Check the fan specifications to determine the correct type of timer switch to use. Finally, be sure to follow all applicable codes and regulations when wiring the bathroom fan. This will help to ensure that the installation is safe and compliant. In conclusion, while it may seem tempting to put the bathroom light on the GFCI protected side of the receptacle for simplicity, it is generally not the best practice. The potential for nuisance tripping and the inconvenience of losing light in an emergency outweigh any perceived benefits. Separating the lighting and receptacle circuits and providing dedicated GFCI protection for the fan ensures a safer, more reliable, and code-compliant bathroom electrical system. Always prioritize safety and follow the recommendations of qualified electricians and the requirements of the NEC and local electrical codes.